So to start off, this golf ball is going to roll down this ramp here, roll across the ping pong table, and hit these dominoes. These dominoes are going to transfer all the energy into this lever, which is going to hit this mini hockey ball, and then hit this marble here and roll down this mousetrap thing. It's going to hit these dominoes again, which is going to knock over this tennis ball, and this tennis ball is going to roll down into the cup, which is going to transfer all the energy to a marble, which is going to come down here into this pulley system that we set up. And this pulley system is going to pull the pencil out, and a ball is going to roll down this plank, hit this tree, and it's going to fall on the ground for my dog to eat. This project also shows conservation of momentum, because when this ball rolled down this ramp, all the momentum is transferred into this domino. The ball's momentum is velocity times mass, and all that momentum from going down the ramp is transferred into this domino. Even though the ball stops, it's all transferred into this domino. Law of conservation of energy is also displayed in this machine. For example, when this ball starts moving from the domino, it rolls down this ramp, and its total mechanical energy stays the same the whole time. When it starts going down the ramp, it gains kinetic energy but loses its potential energy, and so the energy always stays the same, and all that energy is then transferred into this marble back here, and it keeps going.
Newton's first law says that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force. So when the golf ball is here, it's at rest until we release it. So it's acted upon by an outside force. And then it's in motion, and it stays in motion the whole way through. So our whole machine won't work unless we make it move, because it needs to be acted upon by an external force. So when the ball hits this and this dominoes, the ball stops because it's acted upon by this force, but then these are acted upon by the ball, so they go. So Newton's second law states that force is equal to the change in momentum over time. So force equals mass times acceleration. So like for example over here, it would be force equals the mass times the acceleration in one direction, because this is a single plane, but over here force would be equal to mass times the acceleration due to gravity, because it's a pulley. So Newton's third law states that for every action there's an equal and opposite reaction. So when the ball hits here and begins the dominoes, because it hits, the dominoes hit back with an equal and opposite force, which causes them to fall. And when it hits the lever, it hits over here, which causes this side to have an equal and opposite reaction and jump up, and so on throughout the whole machine.
Yeah.
All right.